Good morning. Welcome to the International Space Station Flight Control and the Mission Control Center in Houston. As you know, one of the things that the space station crew really focuses on is getting the information we need to be able to send crews farther than ever into deep space. And the spacecraft that we'll be doing that with is the Orion. It's being built at Kennedy Space Center, getting it ready for its first flight test coming up in December. But in the meantime, we actually have a parachute test scheduled for Wednesday, and we have Lara Kearney from the Orion program here to tell us a little bit about that. Thanks so much for joining us, Laura.
Sure, my pleasure. Glad to be here.
All right, so tell us a little bit about Orion and the parachute system that we're going to be testing on Wednesday.
Okay, we have a very complex parachute system. It's obviously a high-risk system. It's what we depend on to make sure the crews get home and land safely. We'll be testing this Wednesday the full sequence of events that lead the parachute system home. It goes all the way from the time the mortars fire, the forward bay cover parachutes, all the way down to the time we land.
So we've done several of these tests, and I know there have been a number of different sequences. We've tried some failures, kind of simulating different things that could go wrong just to be sure that we'd be okay even if they did. But this is going to be the full sequence, and I think you mentioned the forward bay cover. That is a cover over Orion that has to go away before the parachutes can deploy, right?
Yeah, that's right. For the whole test sequence, we'll actually deploy out of the C-17 at about 35,000 feet. And the spacecraft actually deploys on a platform, and it is released from the platform, and then it is under what we call programmers, which puts the test unit at the right test conditions.
Gets to be like kind of like flight, right?
That's right. We want it under as flight-like conditions as we can get it. And then we'll start the actual mission sequence. And so you'll first see the forward bay cover parachutes deploy, and then you'll actually see the forward bay cover itself jettison. And then after that point is when the main parachutes will start to their sequence. You'll actually see two drogues come out first, which will slow the vehicle down. And then it's followed by the three pilots and the three mains, which the vehicle then lands under.
Okay, it takes a lot to get Orion safely down, I guess.
It does, and everything has to work just right. It's all timed just right, down to the split second when things need to fire to make sure that we don't have any contact among pieces of hardware. So there's a lot of detail that goes into making sure the sequence works just right.
And I guess, let me make sure I can get the numbers right here. So I think Orion will be coming back from a very high orbit, 3,600 miles, which is farther, about 15 times farther than the space station orbits, and coming in at a speed of about 20,000 miles per hour, and needs to slow down to 20 miles per hour. So the Earth's atmosphere helps us with that, but then it's all up to the parachutes.
That's exactly right. That's the job of these chutes.
And of course, we want it to work because eventually we'll have people inside Orion, and they'll want to splash down at a little slower than 20,000 miles per hour.
That's right. For the flight, we'll be splashing down on the water. Here for this test, we'll be in the desert in Yuma, Arizona, but for the flight, we'll be touching down in water.
And we've been to Yuma a number of times and done a few of these tests, right?
We have. This is the 14th test in our test sequence. The test team has become just experts at getting this down. It takes a lot to pull a test like this off because there are a lot of people involved, not just the NASA team, but the Air Force and all the other folks that are out there making it happen. So it's a complicated test.
Have they gone pretty good so far?
They have really gone great. We've learned a lot. That's why we test, is to learn things. And so in every test, little things will go wrong, and the test team is able to bring that data back and fix it and tweak the hardware. And so a lot of what we learn has been incorporated into the EFT-1 flight hardware that is already installed in the ONC down in Florida. So we have actually brought down a lot of risk by flying these test flights and increased the reliability of the overall system.
And hopefully we feel pretty confident then that they'll work well on this first flight test. That's EFT-1, Exploration Flight Test 1, and again, that's in December.
That's right. This test will also have some of the ground crew, the helos from the Navy, and some of the folks, the chase aircraft will be out as well. They'll be using this test as sort of a dry run for the EFT-1 recovery operations as well. So that's sort of a secondary objective at the same time.
Okay. Well, I hope it all goes well. Thanks so much for coming and telling us about it.
My pleasure. Thank you.